I am Dr. Susanne Schwenzer and I am a senior lecturer in the School of Earth, Environment and Ecosystem Sciences. I'm a mineralogist, I'm a planetary scientist, and I am also a senior lecturer, which means I do research, I do teaching, all about mainly Mars, but also Earth. Mars because it's a planet that is very, very fascinating. Mars, you can see the 4.5 billion years of history of terrestrial planets. We see how all the impact craters happened in the early times, and then we see the evidence of flash floods, the water, the climate change to the dry Mars we do now. And so I actually got into this through the Martian meteorites when I did my PhD. I wanted to study some noble gases, and the samples happened to be meteorites from Mars, and that's when I caught the Mars bug. In 1964, Mariner flew to Mars to take some pictures. But when those pictures returned, all we could see was a lunar-like landscape with the craters. And that was because of the resolution, because these orbiter pictures were from far away and they didn't have much resolution. So you only could see the biggest features on the surface of Mars, and these were the craters. Later, other Mariner orbiters had a better resolution, sent back more detailed pictures. And then we saw the river channels and we got all excited again. And in 1976, the Viking landers landed. We today have several orbiters around Mars. The United Arab Emirates Hope orbiter made some headlines, but of course there are NASA and ESA orbiters in the orbit of Mars for such a long time that we always forgotten that it is quite a feat to have them. And we had some rovers. We had mobile platforms that could take pictures, that could even do chemistry on Mars. And now we have rovers that collect samples. It was first the Sojourner rover, a tiny little thing that just roved around and got a little bit of chemistry, but it paved the way for the MER, the Mars Exploration Rover, Spirit and Opportunity, who had much more capable instruments. They were also bigger. And then we have Curiosity. It landed in 2012 and it has been exploring Gale Crater ever since. And it has instruments in its belly where it can take gas samples. It can look for organics. And now we've got Perseverance at Jezero Crater. That rover collects samples. It has just put the first set of 10 sample tubes down in an area that's called Three Forks. We now have samples on the surface that we can collect in the 2030s. And these samples shall come back to Earth, and we can then investigate them with all the instruments that we have here. But Perseverance keeps on rolling. It's actually got an identical sample set in its belly, and it's going to collect more samples. And if all goes well, we will get more than these 10 samples. So we're living in a really interesting time with 2 active rovers on Mars, and we will keep exploring. First of all, we have sample return. We are collecting the samples right now. The Perseverance rover and its team is making sure that we get a really representative set of samples. And so there will be a sample return mission. But of course, there are also other missions. And I just want to highlight one of them here, and that's the ExoMars rover. ExoMars is doing something really different. Curiosity and Perseverance, yes, they drill, but they drill for sampling about 6, 7, 8 centimeters deep. What the ExoMars rover will do is it will drill up to 2 meters. And that's interesting because we are looking for life on Mars. And the Martian surface in its upper centimeters is a really hostile environment because the Martian atmosphere is so thin. And if you have a very thin atmosphere, you get a lot of cosmic radiation. And so organics change all the time when they are exposed to this radiation. But rock protects the organics from that radiation. So drilling really deep and getting a sample from 1 meter or 2 meters down below the surface will be really important to understand what the original organics look like. And that's what ExoMars is going to do. I think, first of all, we will keep investigating with the instrumentation that we currently have. We've got 2 rovers on the surface of Mars. They are both going strong and they are both daily returning new data and really, really exciting new data. So that's the near-term future. But also here on Earth, we have the Martian meteorites, and we will continue to investigate them. And we will continue to do what is also really important, and that is analog work. We will create simulated environments in the laboratory, which is something we do here at Astrobiology OU. And these simulated environments are one way to study and predict and understand what we are looking for. But we can also go out on Earth and study what we call analog environments. Let's say we can go to the Netwetwe Pan in Botswana and we can study how the microbes interact in this dry and salty environment with the layers of the sediment, how biofilms form on the surface there, to then understand how would that have happened. In science, you always stand on the shoulders of the giants who did that research before you. But then, of course, we've got the new missions. We will get samples back in the 2030s. We will investigate for the very first time samples that we have collected, where we exactly know where they are from. And studying those will bring up new insights, and we will hopefully understand if there ever was life at Jezero Crater. What excites me is to know something today that no one knew yesterday. When we started out at Gale Crater, we thought, yeah, there was a lake there, but we never could have imagined the variety, the diversity, the changes in sea level, the complexity of that scene on its own. And that's just one place. So keeping exploring, getting more samples, going to different places, doing different things, and adding to the understanding is actually really exciting. Well, the future is always something that's really hard to predict. Of course, we've got to get it right. And that's what lawyers, governance people, planetary protection people do. However, for me, really personally, I'm over 50 years old. When the samples come back, I'm very close to retirement age. So I look at this and think, we need the future generation to step up and step in here. It's for all the youngsters who are in school today, who are at university today, to take over from my generation, who has made the mission possible, who has put the rover on Mars, who gets the sample back. But then we are going to retire. So the most important message for me is we need to make sure these samples are well kept and can be studied in 50 or 100 years' time after they have been returned by future generations, some of whom will not even be born now.